Welcome students. I welcome you all in my classroom. I Mr. Kunjaveer Sahu, Assistant Professor, Department of Electrical Engineering, Prince Polytechnic. Today I will teach you a small portion of GTT paper which is belongs to your fourth semester, period number 4, and I will teach you today the chapter number 3, overhead lines SAT. Overhead line SAT. So what is SAT? How we can calculate? We will see today. So particularly after the generation of electricity, we can transmit that electrical power for the far away long distance by the help of conductor and support. Suppose this one is one support, let it be A. This one is another support. This one is point B, and you can direct the conductor from A to B. So, what is the definition of sag? Sag is nothing but it is defined as the difference of level in between point of support and the lowest point of the conductor. It is a difference of level in between point of support and the lowest point of conductor is nothing but called sag denoted by capital S. Okay. So why is calculation required? Because if you can shape your conductor, somebody gives so much stretch of the conductor like this. Suppose this one is to support, and if you are stretching the conductor like this, then what will happen? Because this is wrong direction. Because in the winter season, what will happen? The conductor should be very much compressed, so that after few days it will break. Okay. Likewise, if you are giving much more deep of the conductor like this, that is also not used because during summer season it will may expand, for which the ground clearance should be very much minimum and electrical hazard may occur. That's why it is mandatory to give the proper calculation, to give the proper sag of conductor, so that it will the conductor should be keep in safe tension. Okay. So how you are getting the conductor in safe? Remember, always give 50% of ultimate strength, ultimate strength of conductor with value of safety factor giving 2. Okay. So if your ultimate strength of the conductor is giving 50% with safety factor values 2, definitely your conductor is in safe tension. Okay. Now we are just calculating sag, how we can calculate, particularly on the basis of our level of area, we can segregate the sag calculation into two ways. One is sag calculation in equal level area and sag calculation in an unequal level area. Okay. So today I will discuss about the sag calculation in equal level area. So let us start. Suppose this one is support A, this one is support B, So this one is the lowest point of the conductor having point O, which is taken to the origin. Let your P is tension of conductor, L is span length, W is weight of conductor for units, and your S is sag. So we can calculate the sag of this system. Now, for calculating the sag, we will take a single point across this, and we know, according to the definition of sag, the difference of level between the point of support, different point of support, and between the lowest point of the conductor, but sag, capital S. So for calculating sag, we have taken a single point P across this OP, and now we can calculate the sag between OP. Okay, so this point P having coordinates of xy, and the distance between OP is x, and the distance, the height in between OP is equal to y. Okay, so what will happen? There are two forces acting on the portion of OP. There are two forces acting on the portion of OP. What are that two forces? The first force act total weight of conductor W. The total weight of conductor across the portion of OP, nothing but x, at a distance of x by 2. That means at the midpoint, this point is x by 2. This point is x by 2. Okay. And another force act is nothing but your, due to OP is a very small portion, and it can approximate a horizontal distance. That's why the tension is act on the horizontal manner, and this tension act on conductor horizontally at horizontal. Okay. So now, if we take the moment of both force, then we are getting tension Ty equals to Wx into x by 2, because the weight of conductor are here Wx. The total portion of weight of in between OP is nothing but Wx, and it will act on the weight of the OP. So what is the value of y? Y is 1 Wx square by 2. Getting my point? So let it be equation number 1. Now, if we can shift this OP point to B point, now we can calculate this, what is the sag. So we have got here y equals to W x square by 2t. So we have got here the y distance is nothing but your Wx square by 2t. Now shifting the point P to point of support B. So if this point is total length L, due to point O is the middle span, so this length is L by 2, and this point is L by 2. So when we consider support B during that time, we can put the value of y equals to S because the distance of y in between OP is shifted to OB. So now the distance in between OB is nothing but your sag S, and the horizontal distance x is equals to L by 2. That means the horizontal distance between O to P is nothing but your L by 2. So according to put the value, put the value in equation 1, then we get then we get S equals to W into L by 2 square divided by 2P. Nothing but S equals to W L square divided by 8P. This is the formula for getting sag for steel air and normal temperature condition. So this is the formula by which we can calculate the value of sag. By this formula of sag, we can get that some factors are there which affected for sag, that is what W. That means sag is directly proportional to weight of conductor W. Sag is directly proportional to span length, and inversely proportional to the tension. That means if tension will be more, sag will be less. If tension will be less, sag will be more. But if the conductor having very much weighted, then your ultimately the sag value is also more. And if the length in between, if the span length will be more, what is span length? The horizontal distance in between both support, which is denoted by L, that's called span length. If the length in between two support will be more, then ultimately the value of sag also more. But it is inversely proportional with the tension of the conductor. If the tension will be more, sag will be less. If the tension will be less, sag will be more. Also, sag it depends upon the temperature in directly proportional nature. So this formula is getting for steel, air, and normal temperature condition. So till now, thank you so much. Next class I will teach you for unequal level area. Thank you.